Hello and welcome to this maths lesson. So today we're looking at section A, lesson 12, and this is on compound interest and depreciation. So today's agenda, first of all, we're going to look at a definition of compound interest so we can understand what it is. Then we're going to look at the formula. Then we're going to look at some example question, 2 examples. Then there'll be a question on compound interest for you to try. Then there'll be a question on depreciation for you to have a go at. So, definition, compound interest. Compound interest is different to simple interest. Okay, so as the amount changes every year, it's the new amount that gets interest, not the old amount. So think of it like this. If I put £100 in a bank and I get 10% interest, in simple interest, that means I'd get £10 extra every year. But in compound interest, so after 1 year, I'd have £110. So instead of getting another £10, I'd get 10% of the 110. Okay, so the interest changes every year. Depreciation is just negative compound interest. So it's when you lose money. So like if you have a car, it goes down in value every year or something like that. So the formula is this: compound interest. So it's A, which is total amount, so the new amount, equals P, which is original amount, and then in brackets we've got 1 plus R over 100, which is rate of interest per annum, which is basically the percentage that they'll give you in the question. Then we've got to the power of n, which is the number of years. So make a note down of that equation if you've not seen it before. So here's an example using this formula. Chris invests £3,500 in a savings account, which pays 5% compound interest per annum. And remember, annum is just the fancy word for year. How much will he have after 4 years? So here's the answer. This is what we'll do. So what we'll do first of all is write down what each thing is. So we don't know what A is, that's what we're looking for. So that's a question mark. P, the original amount, is £3,500. R, which is the rate, is 5%, so it's positive 5%. You could write that if you wanted, but we'll just assume it's positive. And then number of years, which is 4 years. Okay, so now we can put everything into the formula. So we've got A equals 3,500, then we've got times 1 plus 5/100ths, all to the power of 4, because it's 4 years. And if you put that in your calculator, you'll get an answer of £4,254 to know decimal places. Okay, so, and that makes sense because he's making money here. So if you've got an answer that's less than 3,500 and he's making money, then you know you've gone wrong somewhere. So here's a second example about depreciation. So Mike has just bought a caravan for £12,000. If the caravan's value depreciates by 8% each year, how much will it be worth in 6 years? So the formula is exactly the same. The only thing that we do differently, okay, is instead of plus R over 100, we do minus R over 100. Okay, that's the only difference. Or you could do plus minus R over 100 because it's the same thing. So we've got A is not, we don't know what A is. P is £12,000. R is negative 8%, and N, which is number of years, is 6 years. So put this into your formula. We've got £12,000 times 1 plus negative 8/100, sorry, to the power of 6. And if you put that in your calculator, you'll get a new value of £7,276 to know decimal places. So after 6 years, his caravan will be worth a lot less, and that makes sense because it will depreciate over time. So here's a question for you to try. A woman puts £750 in her savings account, which pays 5% compound interest per annum. How much will she have after 10 years? So give this a go, pause the video now and use the formula. I'll go through the answer in a minute. All right, so the answer is, so what we're going to put the values into the formula. So I've not wrote the formula out this time because hopefully you've already written it down. But if you've not, you can go back in the video to have a look at it. So we've got A equals 750 times 1, and this is going to be plus because she's gaining money. So it's going to be 5/100ths, and that's going to be to the power of 10 because it's 10 years. N is 10. So she now has £1,221.67 in her bank account. So she's made quite a lot of money here, but it's been 10 years. So that makes sense as well because she's making money from interest. So here's a question for you to try again. Question 2, this is on depreciation. So remember to do the negative r over 100 part. So Susie has just bought an antique clock for £57. The clock depreciates by 0.5% every year. How much will the clock be worth in 30 years' time? So pause the video now, give it a go, and then I'll go through the answer. Okay, so the answer is, so we put everything into the formula. We've got 57 times 1 plus negative 0.5 over 100 to the power of 30. So you may think this is going to be a really small number because it's a long time, but the percentage is really small, 0.5. So when we work out the clock, it's actually only lost value by £8, so it's now worth £49, okay? And that is the answer. So thank you for watching this video. I hope it was useful. If it was, please subscribe, comment, and like this video. If you have any questions, just comment and I'll try to answer as soon as I can. Goodbye.